No, 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 no.
You won't be afraid of losing power on a scorching summer afternoon after you see what this simple bucket can do. No air conditioner, no generator, just a few everyday materials that almost anyone already has at home. It sounds impossible, but by the end of this video, you'll know whether this homemade cooler is a clever solution or a complete waste of time. Welcome back to Dan Fix. I'm Dan. First, I need 3 empty plastic bottles and 1 old paint bucket with a lid. This bucket looks simple, but the location of these first holes will decide whether the cooler actually moves air or just traps it inside. I remove the bottle caps and use 1 cap as a template. I place it near the upper side of the bucket just below the lid, then trace the circle with a marker. I repeat the same step 3 times, spacing the marks evenly around the bucket. These will become the air outlets. The reason I place them near the top is simple. The fan will push air down into the bucket, and that air needs a clean way to escape after passing around the ice. If the outlets sit too low or too unevenly, the airflow can feel weak. After the holes open up, I trim the edges with a knife until each circle looks clean. A rough edge can block airflow or stop the bottlenecks from sealing tightly later. At this point, the bucket finally has 3 exit points, but air still needs a strong force pushing through it, and that is where the fan comes in. Now we move to the part that turns this bucket into a real air-moving system. I place a 12-volt exhaust fan on the bucket lid and check the size carefully. The fan frame must rest on top of the lid, not fall through the opening. That is why I trace the inside of the fan, not the outside. This gives the blades room to pull air down while the square frame still supports itself on the lid. If the hole gets too large, the fan will sit loose and the cooler will lose pressure. Now, I cut along the marked circle with a sharp knife, moving slowly around the line. After removing the centerpiece, I test the fit. The opening lines up with the blades and the frame still overlaps the lid. That is exactly what we need. Next, I add hot glue around the fan frame and press it onto the lid. The glue seals small gaps, so the fan pulls air through the bucket instead of leaking around the edge. Be careful with fresh hot glue because it burns fast. Now I connect the fan wires to a DC power jack. Red goes to positive, black goes to negative. To make the jack easier to handle, I glue it onto a plastic bottle cap as a small support base. Now the lid has the fan and power connection ready, but the air outlets still need proper sealing. Let's turn those 3 rough holes into proper air outlets. I take the plastic bottles we prepared earlier and cut each one near the neck about 1 inch below the threaded section. These short neck pieces will work like simple fittings. The idea is the same as a connector in plumbing. One side goes through the wall of the bucket and the cap tightens from the inside. When the cap screws on, it pulls the plastic neck tight against the bucket and helps seal the gap. Before installing them, I drill a hole through each bottle cap so air can pass through. If the cap stays closed, the outlet would look finished but block the airflow completely. After drilling, I clean away any rough plastic so the air path stays open. Now I push one bottleneck through the hole from the outside of the bucket. From inside, I screw the drilled cap back on and tighten it by hand. I repeat the same process for the other two outlets. Now the bucket has 3 sealed vents instead of 3 loose holes. This matters because every air leak steals pressure from the fan. With these outlets locked in place, the homemade cooler starts to look much more like a controlled airflow system. Now I come back to the lid because hot glue alone may not hold forever. Cold air inside the bucket and vibration from the fan can loosen it, so I add a stronger mechanical connection before testing. I mark 4 screw positions around the fan frame, then drill through the lid at each mark. Now I push the bolts through the fan frame and lid add washers underneath and tighten each nut evenly. The washers spread the pressure so the plastic lid does not crack or pull through. This upgrade matters because the fan has to stay sealed and centered. Any gap around it will steal air pressure before the air reaches the ice. Next, I prepare 2 power wires long enough to reach a 12-volt battery safely. One end has alligator clips, and the other end connects to the DC plug that powers the fan. Red goes to positive, black goes to negative. Do not guess here. A wrong connection can stop the fan or damage it. After joining the wires, I slide heat shrink over the splice and warm it until it grips tightly. That protects the connection and keeps the wires from touching each other. Also, keep this electrical connection away from melted ice water later. Cold air is good. Water on exposed wires is not. Now the moment of truth begins. I clip the red alligator clamp to the positive side of the battery, then connect the black clamp to the negative side. The fan starts immediately, and that is our first good sign. But spinning is not enough. I need to know if the air actually moves through the bucket and exits the 3 vents. I hold a light thread in front of each outlet, and you can see it blow outward strongly. That means the fan pulls air into the bucket and pushes it out through the bottleneck vents. Now, airflow alone will not cool anyone down on a scorching afternoon. We need ice. I pour a bucket of ice into the container, spread it across the bottom, and close the lid tightly. If you build this for longer use, add an insulating layer inside the bucket so the ice melts slower. The room temperature starts at 34.7 degrees Celsius, which feels hot and heavy. After the fan pulls air across the ice, the thermometer begins dropping fast. In just moments, it falls through the 20s and reaches about 15 degrees Celsius at the outlet. That is the proof. No air conditioner, no generator, just a bucket ice, a 12-volt fan, and controlled airflow. If you found this useful, hit like, subscribe to Dan Fix, and tell me what summer problem you want to solve next.